Blay pi baro ki bapa ikani ke video yang subhai pi share ni ke channel ke Tech Tutor Meghalaya bala penni da ke SCSTE. Kerteng janga kalong iba pediam hun kamwil but hakani ka porpan ngan batai pi shapangka Electric Flux. Di shwabangin batai shwabangan discuss shapangka ni ke Electric Flux ngukwa ban discuss shapangka way ka term ka bangan ngin sapenan kam shibit, alright? Kalau kabadan kam na finsungut ho shwai kata kadai ka area vector. Te hakin ye class bal hashwa fila puli shapang ka area. Fila puli shapang scalars and vector quantity, right? And but ni ong ba ka area kadai ka scalar quantity namar ban measure ka area. Ngindal kam find ka direction you should measure by kum no should ka area of rectangle. You should calculate by length into breadth. That's it. Nilayo ay ka area. Ngindat kamre banwat ay ka direction jong ka area. Alright? Hinray mintapat. Okay? In physics, kidan kindiat katugan ni ki physical quantities. Alright? Kibadan kam ban define. Baka ni ka area ka pai siya ay. Alright? For example, nginyapit minta kinilay tali kinuksa ki bangan IFA. Tementa pi kini lai tali kinuksa kini diagrams nga draw hang ni, but hang ni nga don kini ka electric field E, alright? Kini ka electric field E kadi ka bayat na ni ka left side, siya right side. The in B also it's the same electric field in all these cases, alright? Same electric field E, hang ni same electric field E, hang ni same electric field E, but nga represent kini ka electric field line suddenly ka electric field line, suddenly ka electric field lines, alright? Tementa, but hang ni example A, okay? Tingin pet minta hang ni flabin ing adan ni lightly ki diagrams A, B and C. Alright? Then all these three diagrams ngadan ka electric field E. Alright? Banga represent the suddenly ki electric field line. Same thing in B, same thing in C also. Nang ta de flabin ing draw ka ni ka area del S. Te finde pet ha ka ni ka example number A. Through kani ka area del S, dan kamtli ki electric field lines ki ba pass through. Done, way, R, lie, south, suddenly ki electric field lines. Pet ka example B pad. Kani ka jo M ka area, ka jo hi ka electric field. Day, tamba pet menta kanon tali ki electric field lines ki pass through kani ka area del S. Dan M ki field lines ki bayat ling ba kani ka area del S. Ong dan re. Tingin niya pet ka example C pad dan kalau tingin field lines ba pass through ke area del S dan way R lie. Te habarot kini lai tali ke example ni E ka way kata kalong ba even though wala da kani ka electric field kani ka juhi wala da kani ka area kani ka ju ke area del S nga shimi kani ka area but nga buah kani electric field nga shimi area nga buah ka ju ke electric field nga shim kani ka area haka joy ke electric field ka ka ba nga change datang karu comply jong ni ka area pinam ka direction jong ni ka area hangni kalong perpendicular to the electric field hangni kalong parallel to the electric field hangni pat kadan at some angle theta, right? Kadan at some angle theta with respect to the electric field. So tang namar baka change kani ka area kor comply finam kini ki electric field line ki bayat ling baga ni ka area ro ki pair no kadan ka jinga pair hangta wala even though, alright, nga bo haka ju hite ka electric field hindi ki field lines hangni ka di maximum hangni minimum hangni ta kalang somewhere in the middle, okay? So tang namal ba karu comply jong ni ka area, alright, ka pair ko example karukom ya jong electric field ling ba ni ka area ro ka pair no. So nakataka daw ni dan kam ban define ya ka area hakane ka example jong kum ka vector quantity and not as a scalar quantity. Namar nakarukom pa nakarukom ka ni ka direction jong ni ka area ken karukom penbet ka pair no ka reading, okay? Jong ni ka electric field lines ki bayat ling ba kini ki area ki jong. Alright? Nakapenta ka ni ka electric flux ngin hap ban batay ka area as a vector quantity, alright? But ngin pet vector quantity kabamot ba dan kam bandan ka magnitude but they bandan de ka direction. Tingin niya pet ngin define kumnoy kani ka area vector. The area vector in terms of magnitude, alright, it is equal to the size of the surface's scalar area. kabamut ba, ngin ken bet normally kumaj ken, for example, the deke area of a rectangle can they be length into breadth, katoka value can they magnitude value bet jonga area vector, whereas the direction pada, it is given by the direction is perpendicular to the surface. Alright? Alright. The kum hang ni kapor, kanika diagram, draw hang ni, kadan kanika rectangular area, kabang draw on the XZ surface. Hakanika surface belong ni apa. Alright? And nga draw kani pada ka circular area on the YZ surface. The hang ni for the rectangular area, once again, the area in can bet using the usual formula, the area of a rectangle, which is length into breadth, alright, kata can give us the magnitude. Now for the vector, alright, if I consider the area, alright, the magnitude is A, fine, now the area is A, alright, the vector is given in which direction is the vector can point? Can they perpendicular to the surface area. Kabamut ba, it is an arrow drawn perpendicular to this surface. So this will give me the area vector, A vector. Fine. Tamba, ka rectangular surface, hatu kadan surface tang madrang. Em kadan syapuar em. So syapuar ngalaban draw sa away line uman represent yung vector uba kadaw syapuar pan, alright? And I can name this A vector, A dash vector. Ta. Bien. U A vector, u kudaw siya draw. Uwe u A dash vector pat, u kudaw siya po. So, area vector, alright, for a 2D diagram. Alright, for a 2-dimensional diagram, kum ka rectangle, square, circle, triangle, and so on and so forth, can done artfully key directions. Alright, go away, can long upper, go away, can long lower. Alright, so we have the upper vector and the lower vector, and the vector belongs to left and vector belongs to right. Fine. The kumhang for this circle. Once again, the area of a circle is pi r square. Take a 2 and give us the magnitude. So let's see if the magnitude is S. Okay. The vector is given again by a line that is perpendicular to this surface. So if I draw a line but not perpendicular, it will be in this direction. So this will give me S vector. Vector uday baktao, alright, away from the surface. Okay, vector uday baktao away from the surface, and it should be perpendicular. Keep in mind, it should be perpendicular. Hang niru uday belong perpendicular to the surface. Hang niru uday belong perpendicular to the surface. And for 2D, for 2-dimensional surface area, can be done R direction. Go away, maybe to the right, and another one is towards the left. So this will give me S dash vector. Alright. Again, uni ulong perpendicular to the surface. Right? Kalau kum kaplia, dabo kum to uwe thosha ni, uwe thosha tai. Okay. Te kata kadena kabenta 2-dimensional. Alright. So if ladang ashim yu area vector, shubudang ashim yu A vector. Fine. Write it in terms of the product of magnitude and the unit vector. I can write it as A is equal to A, which is the magnitude, into, alright, my unit vector, which is n cap. What is n cap? What is n cap? N cap is the normal unit vector. Alright? N cap is the normal unit vector. Normal kamut kumno, normal kamut perpendicular. Kamut ka direction ka even long perpendicular. As you can see in all these cases, the vector is perpendicular. Alright? Unit kamut, the value is 1. Alright? So it's a unit vector that is perpendicular to the surface. I hope pila smooth ho ekata. To, nakabenta 2D ngila define area vectors kilong kumno. What about for 3D diagrams? What about for 3D diagrams? 3D diagrams but there, as you can see, in a cuboid, dan kanali surfaces, alright? Kadan kani surface, fine. Kadan kani surface, and you have this other surface also. And nashata ka side udan, tinang tadi nashni ka side udan, alright? maybe I can draw it with dotted lines. Alright? Te nashte ka side kadan, nashni ka side dan shapo ru kadan. Right? Kadan hadu 6 surfaces. Fine. Tang ba u area vector for 3DM ni shimbet tang ki belong outwards. Outwards kamut ki di bentau bet shabar jong ni u object. Ki di bentau bet shabar jong ni u object. Ki di bentau bet shabar jong ni u object. Alright? Nang niru ki di bentau bet shabar. Shapor ki di bentau bet shabar. Umdan ra u vector, area vector for 3D, alright? Nim ju consider u batau shapor. Nakabenta 2D batau shadrong ba shapor, sha left ba sha right ni shim lang. Henry for 3D. For 3D objects, ni shim ki area vectors ki batau only sha bar. Alright? Nakabenta sphere ki 3D objects ki di bentau bet sha bar only. In all directions, ki di bentau shabar kini ki vectors. Alright. So each of these vectors again ki di belong bet kumlo, ki di belong perpendicular. Ki di belong perpendicular bet to this surface. Alright. Ki di belong perpendicular. Alright. Even for the sphere also, these vectors they are perpendicular to this surface. Kumba fila pulih ha class 10 yang try fila learn shapang the relation between the radius and the tangent, right? So the radius, do you see kini ki vectors n kini belong along the radius of the sphere. Each of these vectors kini belong along the radius of the sphere. And if I draw a tangent at this point, alright, the radius and the tangent, they are always perpendicular at that point. So at each point, at each point m, ngan shim tangent ngan draw, alright, and that point kadi belong bet perpendicular. Okay, so therefore these area vectors, alright, all of these area vectors also perpendicular to the surface of the sphere. Okay, kilong perpendicular, kilong 90 degree lot kini baro. Alright, so kata kabafidan kamba note down once again, area vector for 2D diagrams in both directions. Alright, and another thing, ki 2D diagrams, alright, for 2D diagrams, for 2D shapes, alright, another name gibang you should call ki open surface. Okay, ki 2D shapes ni should on ki open surface, whereas for 3D shapes for them, ni should on ki closed surface. Alright, and then you can punky open surface objects. We are talking about 2D shapes, ki rectangle, square, triangle, so on and so forth. And then you can punky 3D shapes, then you can punky closed surface, sorry. Then you can punky closed surface, kabamut yaki 3D shapes, like cuboid, sphere, shell, alright, cylinder, and so on and so forth. Okay, then it's can plus ngot ho ikan ni gajing batai jong area vector timintang in yat kabadan kam ka discussion ji kabadai shapangka electric flux. Then what is electric flux? Electric flux over an area in an electric field is a measure of the number of electric field lines crossing this area. Kat notli ki electric field lines, for example hang ni kum tu mga example hakaman ki cross ye kani ke area del S janga, alright, kata ka represent ye ka electric flux. And the number of field lines crossing this area element is proportional to E into del S. Te kani ka represent ye kata ka electric flux. The electric flux is denoted by phi. Okay, don't use symbol phi, it should represent ye ka electric flux. Okay. The minta hangye board ngadon oddly diagrams, alright, number A and number B. If in the pigmenta in the example A, alright, I have both, alright, in these diagrams I have the same area, del S and del S. Kabay perdik A, electric field. In the first example, in example A, ngadon electric field which is represented by 2 electric field lines. Kadba in the second example number B pan, ngadon electric field E2 but represent the southerly electric field lines. They have bakumta kakran ke electric field 2 ne, electric field 1 ne. Electric field 2 klan banyak electric field 1. Remember, electric field ni represent lagi electric field lines. The more the electric field lines, katangi represent ni gajing klan jangka electric field. Ada electric field lines ki duna, kabamut bak electric field katulat lani ka duna. Okay. Te hang ni pindapat. Which of these two, alright, will have more flux? Example A and example B will have more flux. Example number B will have more flux. Mabalay ki bon ki electric field lines ki ba pass through ke area del S. Keep in mind, ke bojumut, ba ke electric flux ke A, the number of electric field lines ki ba yatling ba ka area. Hagni ke area kadika jo hi del S del. Tambah hani kan tali electric field lines ki yat only artli kat bahang ni pat hado southly. Kabamut ba example B represent more flux. Then nang ni ngisngot ho ba ka flux, alright. Then nang ni ngisngot ho ba ka flux. Okay, number 1, ka flux ka depend on the electric field. Ada ka electric field ka klan, ka flux ro ka bon. Alright? Ada ka electric field ka tulad, ka flux ka duna. Then minta pat have another situation. Okay, the hang ni part, I have the same electric field, A, but change the area. Hani nga dan area barit delta S1, hani area bahe delta S2. Then again, between these two example A and B, which one will have more flux? Ka flux, ka buon haka example number B. Namara in example number B, through this area delta S2, how many lines ki pass through? 1, 2, 3, 4, 5 electric field lines. Santali ke electric field lines ki pass through ke area delta S2. Through the area delta S1 electric line ki pass 1, 2, 3. Only 3 electric field lines ki pass. Then na ka dierong is ngot ho ba the flux ka depend on the area. So number 2, alright, flux depends on the area delta S. So these are the two things baka flux ka depend on. Then nakatadaw yung baka flux, alright, the combine ng artli, ang ka flux ka depend on E into delta S. Tibantay nipit biyang ito kanuksa kabaning kong damdo kabang lalit manet. Te hagan niya kanuksa ng iba done the same electric field. Okay? E. Next thing, ke area ro kadai ko maju delta S. Hene ka bay pair hani ka digay. Karukam pi jongka area. Hangi, alright, if I draw the area vector di banong kumno again, it should be perpendicular to this surface. So my area vector in this case, it points in that direction. So this is my delta S vector. Fine. Then yang ala abang thoru ba pi shadil. Okay, delta S dash vector. Okay, the hang near root delta S again vector given on perpendicular to the surface. So pi should wrong delta S vector shapo undan delta S dash vector. Here again, keep in mind udi long bed perpendicular. The em kan ka surface kalong pi kumto. Te uni area vector udan shapo. The perpendicular given on perpendicular to the surface and kumne. Tika bamut bala daga surface nga bukom ni area vector pi shati. So now takadaw, this is my area vector right now hangnya. Okay, uni ulong perpendicular. This is my delta S vector. Alright. Similarly, shadian ru di bandan delta S dash vector. Alright. The both in these cases, kini diki area vectors. The in this case, ladaw area vector ulong same direction as the electric field. Maximum number of electric field ki pass through kanika area, right? What is the angle between this delta S vector and E vector? The angle theta is 0 degree. Pasha jote E rushatai, delta S rushatai. What is the angle hangni? Thau kadai 0. All right. So hangni in this case, but look at delta S vector and E vector. Delta S vector done should wrong. All right. E vector part udan shatai. Ka angle dik ano? Ka angle kadai 90 degree. So theta hangni day 90 degree. The pit ka flux kadik ano? How many lines ki pass through kanika area delta S? Is there any line that passes through delta S? No. There is no lines that passes through delta S. Teka flux hani kalong no? Zero ken. Alright. Remember E into delta S. Lada mdandre iwe electric field pass through kanika area. Alright. The flux is zero. Hangipan all of the electric field lines ki pass through the area. Ka flux kalong no maximum. So I can see here in this case, alright, flux is maximum. And in this case, pada ka flux phi is minimum. Alright? Maximum in the first case, minimum in the second case. What about the third case? What about kanika case ka ba lai pada number C? Fi inam ki area vector ka thosha thiesha po u equal thosha tai. Right? Take angle between them kalong ano. I can take the angle between them to be theta. Any random angle theta. They find the pet electric field lines. Kidang don hi am ki ba pass through kanika area. So therefore, kabamot ba hangding ilalapa kani ka flux ka depende, alright, on the angle, alright, this theta, kani ka angle theta between the electric field and the area vector, alright, depend on the angle between the electric field and the area vector. Te kata kanang he ka angle, lada ka angle ka day no 90 degree, ka flux comes no minimum kanang pass through any lines through the area. Tanda ka angle ka de 0 degree kalong small, right? Ni iba ka flux kalong he kalong maximum. Okay. Then now mentang in your what ika formula, alright, ka bangila ban shimi kata formula ban calculate ika de electric flux for any position of these, alright, area vector for any Tementang in your what no ka formula, alright, nang kabenta ka electric flux, kabangila ban calculate, alright, for all the three cases. Okay. Tementang ala shimhani, alright, but kani ka surface area, it is at some angle theta, alright, this area vector, it is at an angle theta with respect to the electric field. Tementa, since I have two vectors, okay, dengan no either and resolve ya uni u E vector into the perpendicular components. Lani and resolve the delta S vector into the perpendicular components. Alright. Te mentang ngan resolve show delta S mo. Ngan persyang show daga ba resolve ya u delta S ngan pet kan long kumno. Alang shimi delta S ngan resolve you ni into the perpendicular components kabamut in terms of sine theta and cos theta. Alright. In such a way, but one of those components can they along E. Keep in mind, way ni kita component either sine or cos, alright, would even they along the direction of E. To. Then nadamali kumta, this is my delta S vector, alright. Then resolve into perpendicular components na your way when they along E and another part here in this direction. To banlang along E unday u delta S cos theta and in this direction part unday delta S sine theta. Alright? Te minta ngalala ban shin, alright? Hajaka ban shin u delta S, nga shim na da u delta S cos theta u banlang in the same direction as my electric field kin. So here finally I can write phi now is equal to E, alright, into delta S cos theta. Okay, meaning it E into delta S only day. Mentang yang aban E into delta S cos theta. Okay, this since baudan cos theta, lada don cos theta ngisyo kadi what kind of a product ngisyo? Nama ba u delta S rude vector, u E rude vector. Ngisyo what kind of a product? Ngisyo ka dot product. So therefore finally u phi, alright, I can write it as E vector dot delta S vector. So this is the formula, alright, jong ka electric flux. Okay, Tementa syubuk pada jika bang resolve you delta S, what if I resolve you U is? Tementa par jika bang resolve you U S, alright? And resolve A, yeah. Kani day by resolving delta S vector. Tementa and resolve not ya U E vector into the perpendicular components in such a way. But way negative components M, uday banyad along ka direction jong new delta S. Fine. Tementa ngan draw kan. This E ngan break into two perpendicular directions. Alright. Way unday shadrang shatay. Way unday shatay shadrang. Alright. And another one unday along new delta S. So this is my two perpendicular components. Okay, along delta S, component unday E cos theta. And component syati syadrong unday E sin theta. Tementang alayo M, kita ki early components. You see along delta S, component unday U, E cos theta. Tementang for flux, I can finally write phi is equal to E cos theta into delta S. Hajaka mangashim UE, ashim nada UE cos theta, but they in the same direction as delta S. Again, if I rearrange this, no, E delta S cos theta. Right? Once again, E vector, E is a vector, delta S is also a vector. Since there is cos theta, what kind of a product is it? Kadika dot product between E vector and delta S vector. So you see at the end of the day, you ikajo ka formula in both cases. Ang resolve yung delta S ro, yung ikatay formula. Ang resolve yung E ro, yung ikatay ka formula. Alright? So now let me do 3 different cases kiban proof yakato ka bang alek example man. Alright? Ka case number 1. When theta is equal to 0 degree. Alright? When theta is equal to 0 degree. So use the formula phi is equal to E vector dot delta S vector or is equal to E delta S cos theta. Alright? Hajaka jong theta mental not cos 0. So for my case 1, phi is equal to E delta S cos 0 degree. What is cos of 0 degree? Cos of 0 degree dash 1. So therefore phi is equal to E times of delta S. Alright, and this value is the maximum value. This is the maximum value. Alright? Tika niye, tika maximum value jong phi. Tika to example manero, kapag nilalaya to the first example number A, you still remember, area vector they parallel to E vector, right? That is theta is equal to 0 and hangtung iba maximum number of electric field lines he pass through that area, right? So ka formula ru ka agree kata. So we have proven that. Okay? Tingin niya bet sa case 2. Alright, the case number 2 part is when theta is equal to 90 degree. Again, using a formula phi equal E dot delta S, alright, E vector dot delta S vector equal to E delta S cos theta. So, hajaka jong theta mentang and cos 90 degree. Cos 90 degree. And what is cos of 90 degree? It is 0. So, nakata daw E into delta S into 0, phi is equal to 0, and this value is the minimum value. Alright? Tika turo ketika example jong katu number B pengilet mana. Where katu ka plane, katu ka area, kalong kuno, kalong ka vector, kalong perpendicular to the direction of the electric field. Te hang tu ngi iba, there is no electric field lines iba pass through katu ka area, right? And tika ni formula ka agree. Kung baka flux is 0. Kabamot ba no electric field lines is passing through that area. Okay? Alright. What if pada nada katu ka area kabangyo dito delta S? What if kared hado kata-kata? Alright. Nada kared ha delta S, alright? Bangi shito if delta S tends to 0. Okay. Delta S tends to 0, kamut ba I delta SM ired hate. Ajan 0 hero. Okay. Tija you then ka formula ngiyo ano banto as d phi is equal to E dot ds. dsm area ibarat ha. Tadang shimi area ibarat flux rendeng no. Ide ibarat tanda kata kadau d phi. Alright. Then examples bagi pelan kam kane kadena kabenta irregular shape kan. Meneng ile kini shapes jong cuboid, jong sphere. Right? What if kadan ka shape balongkum ni? What if kadan ka shape balongkum ni? Can find kum no ka area. What is the total surface area jong ni? Can you find delta S jong ni ka shape? Ngin la, right? Tadade kum ni ngin le kum no ngin haban shape me kani surface area, bang haban pyak ki berit ki area, alright? Ngin haban shape area berit hang ni, alright? Let's say itu area hang tu ngin haban shape another area ds hang ni, alright? This is ds, this is ds. Alright? Then ang masyami di area ds. Alright? Ni pial baro. Alright? Ni find ko flux through this area ds berit hadin katupat ni sa combine biang. Teban combine ngin haban le kumno ban find the total flux limbakan ni barok had ngin le integration. Alright? Tingin sa integrate E dot ds ngin siyo ya kanika total flux. Kani deka total flux. Alright? Kani pada ke area kani di ke flux through ds. Kemudian ke flux through ini area berit. Alright? Then kani de another form. Alright? Jongka formula jongka electric flux. Dengan ngets kam filas ngotho ega tuga jing batai jongka electric flux. Dengan saya syampat yapi kawi ke video kabangan batai pad sa syapangka Gauss law. Bless you.